This is number 9, which is our differentiation in class practice that we did for today. So I'm going to do a video for each one of them. So this is page 167, number 39. And it says, find the interval or intervals where the graph is differentiable, continuous but not differentiable, neither continuous nor differentiable. So the first thing I want to just remind you, and I know that you have done this in your notes, was to discuss when is a function not differentiable. And when I say that, when it's not differentiable, that means there's no derivative there. So here are the cases we'll go through. The first one is if it's discontinuous. That's the main one. I always check for continuity first. The second one I look for is if it has a sharp corner. And you'll see some textbooks will even say if there's a cusp there. The third thing I always look for is if there's a vertical asymptote, a derivative it's not differentiable there, a derivative doesn't exist. A vertical asymptote. And those three are the only ones that are going to be, in this case, something we'll use. So let's look at this graph we're giving here. And I want to start labeling. So I kind of gave the 3 cases that are going to be applicable here. And I look at it and it's continuous everywhere, except I see right here it's not continuous and here it's not continuous. So I'm going to say this one, it's not differentiable, and this is -1, -2, that's -4. So I'm going to put number 1 because there's a break in the graph here. So that's a number 1, that's discontinuous. Then I come along, it's continuous, and then, I have a sharp corner. So this is number 2. There's a sharp corner at -1. And then I look at, I didn't mean to do that. And then I look at, so this is a -4. I just wanted to make sure you saw that. Then I look here and I say, wait a minute, what's going on here? It looks like on the right side of the function is going up forever. I'm like, right here at 2 is a vertical tangent line. So at number 3, I put that there. That's the case here. There's a vertical tangent line, and then everywhere else it's continuous. So I kind of went through all the places where there's no derivative, or it's not differentiable. So let's do the first one. It says please find the interval or intervals where the graph is differentiable. So I was asking this in class, and someone says, all the other places except for at 1, 2, 3. I go, that's right, but how would I write that? So we're going to pretend this is negative infinity, and this graph goes forever, even though there's really not an arrow. I'm going to put it here, so this is positive infinity. So I'm going to say, from negative infinity all the way up to -4, there's a derivative. It's continuous there. In union with, and then I go from -4 all the way up to -1. And I want you to notice that I'm not putting brackets here because I don't want to include the endpoint because it's not differentiable there. And then I go in union with -1 all the way up until 2, that interval, in union with 2 all the way up to positive infinity. Now, if this was the entire graph, I would change positive infinity to 6 and this over here to like a -5. But I'm going to say this graph goes forever. So that is my intervals where it's differentiable, meaning there is a derivative there. So they're differentiable on all these intervals, okay? The B part, which you can't see, which is above, says where is it continuous but not differentiable, which means you don't pick up your pencil, but there is no derivative there. And as I go through here, I picked up my pencil here and I come up here, I'm like, I pick up my pencil there. It looks like it's only at number 2, and number 2 is the sharp corner, and that's at -1. So I'm just going to show it like this, at when x is -1. Or you can say when x equals -1. I prefer you using the brackets, and if you can see, it kind of fits right in here. It's right in that spot there. The C part asks you where it's neither continuous nor differentiable. So I look at this graph here, it's neither continuous, so it's only going to be here at 1 and at 3. So I'm going to kind of move it up a little bit so you can see 1 and 3, where it's neither continuous or differentiable because it's not continuous and there's no derivative there. So I'm going to put that there. So when I write that, I'm going to say, well, that occurs on the interval -4 in union with 2, when x is 2. Or you can say when x is equal to -4 or 2. I prefer the bracket notation. So I just want to give you this little saying here. I always remember this, and it's got its basis in logic. Differentiability implies continuity. Okay, so if I said it's differentiable, it implies that it's continuous there. But if I were to switch this around or use the converse, the logical converse, it's not the same. If I said continuity implies differentiability, that's not true. So the converse is not true, or the opposite. And I just wanted to put that out there, that you can look at it, and if it's continuous, it doesn't necessarily mean there's a derivative there, but if it's differentiable, you know it's probably continuous at that point. So that's it for this video. I'll put the other two up.